All right, welcome back, everyone. Today we're going to do the Kubernetes theme that RangeForce has put out for the month of June. Looks like we have 5 mods here, so we can start with Kubernetes overview. You're a web developer. Your company needs to create a web server to host a climate survey for the HR department. The web server has to be accessible outside the company with high availability. You're curious about how containerized applications work and how you can orchestrate your own environment in a reliable manner with something like Kubernetes. This module will answer these questions. Okay, orchestration. I'm going to read through this. All right, mod 1 is done. Let's move into Kubernetes introduction. All right, so we need to start by installing Kubernetes in our environment. It wants us to do this through micro K8's micro Kubernetes package on the desktop using Snap. Copy that, open a terminal, paste it in. Let this install. All right, installed on the desktop. Easy enough. Simplify the interface. Kubecontrol is a command line tool for controlling Kubernetes clusters. In order to use Kubernetes in a user-friendly way, you can create an alias and enable autocomplete for your kubectl command, kubecontrol command. All right, so we're going to create an alias for exactly that. So that is the default command that you would have to type out, and it wants us to just make this as an alias. So we had to be as root, as root. All right. Now we are root, and we can create the alias. Looks like we need to vi bash aliases, and we will add in this alias kubectl equals micro k8 s dot kubectl. All right. Escape colon wq bang. Goodbye then. Sweet. Next. Enable bash completion. It is helpful to have tab completion for that alias we just made. In order to prevent conflicts in user namespace command called blah blah blah. To enable bash completion, you need to execute this. But if you want a permanent solution, then you need to append it to bash rc like this. Enable bash completion, okay. Copy this. I don't want to vi into it, so we will that in. Sweet. Create a pod. All right. 2020. kubectl run command syntax change. Now it's kubectl run. No longer creates deployments jobs. It only creates pods. You always use the latest version of microkate. In general, kubectl on a Kubernetes, you'll execute kubectl version to check that it is running properly. All right, let's do that. All right. All right, it is running. So now we're going to do kubectl range pod run range pod. RM p image nginx. This command will create a pod for the bash for the developer to ping or curl and test. If you do not see a command prompt, try pressing enter. All right, we're in range pod. Next. Validate a pod. To check the status of the pods, you can use the kubectl get pods command. And the title. Welcome to Nginx. Nice. Cleanup was already done. By creating environment you can use in production. Create a new deployment on a Kubernetes to host your organizational survey. You can do this with the kubectl create deployment command. Name it rf deploy, image, httpd. Okay. Deployment. Name it rf deploy, image, httpd. Created. Analyze your deployment. Okay. kubectl get all. How many components has deployment created? So 1, 2, 4. Validate your deployment. Now check if your deployment is up and running by sending a curl request to the pod's IP address. So we did this in the last one. List the pod to find its IP address. Validate that the web server is running. Okay. So kubectl, get pods, pod name, rf deploy, tag o wide. Okay, that is the correct name. So it's going to be rf deploy tag 5b 86bcdd7. Wish I had that tab completion. Tag o wide. This is 10.163.2. What is the sentence written in the H1? It works. Scaling replica sets. For fault tolerance, you need to scale your number of replicas. You can do this by using the kubectl scale command. Alright, took it anyways. Watching Kubernetes work. Check the work of the replication controller. You can do this by adding the techw or tech watch to kubectl get pods. Okay. W. All running. And the age. 0 restarts. Delete a pod. Check if your deployment is working. You can delete a pod and see if the replication controller is doing its work. kubectl delete pod name command will get one pod inside of your deployment. Open a new terminal window and use it to delete a pod from your deployment. Keep on the eye on number of pods in the other terminal window. Let me copy one of these. New tab. kubectl delete pod name. Terminating. Terminating. Now your test is successful. Time to clean up. With your watch command terminal still open, delete the deployment. Okay. kubectl delete deployment. deployment name. God, what was our name? Oh yes, RF deploy. Deleted. Now everything is terminating. Now you need to verify that your deployment and services are really gone. Use kubectl get all again for that. Okay. What is the name of the remaining service running inside your Kubernetes cluster? Service Kubernetes. All right. Create a deployment. You can start by creating a deployment to host a web server. For a new terminal, create it. All right. kubectl, create deployment, deployment name, RF deploy, image, HTTPD. Create it. Scale your deployment. You need to scale your deployment in order to have fault tolerance. 5 replicas. Okay. Deployment scaled. Create a cluster IP service. For other apps in the cluster to have access to your service, they need a port to connect to. Try exposing a port in your deployment. Okay, port 80. kubectl, expose, deployment, deployment name, RF deploy, port 80. Deploy exposed. Inspecting cluster IP service. Validate if your pod is responding via DNS to other pods you need and to be inside the cluster. Single interactive pod to validate that. Okay. Create an interactive pod. In order for you to test your services responding via DNS, you need to be inside the cluster. So create an interactive pod inside the cluster. Okay. Run. Name it temp. RangeForce pod. Image is going to be RF Ubuntu local image. Command inside container. Run a bash. All right. We are now in temp RangeForce pod. Now you need to validate that your service is responding inside the cluster via DNS and a port. You can do this with the curl utility. Curl deployment name. Port 80. It works. Cool. All right, last one. Node port and load balancer services. To allow external access to the application you are developing, you need to expose it to either node port or load balancer. Okay, let's do it. Desktop is .1, server is .2. Use SSH to connect to the server. Username, password are student. Okay. Server was 192.168.6.2. Student. Create a deployment. HR team has asked you to create a deployment to host a web server for organizational climate survey. Create a deployment. Create a deployment using kubectl create commands. Okay, pretty familiar with this by now. So kubectl create deployment. Name is going to be rf deploy. Image http deployment created. Scale your deployment. Scale your deployment to 3 replicas. Okay. Deployment scaled. Using node port services. In order to give external access to your web server, you need to expose your pod's services. Okay. Going to be node port service rf tech np container port 80. Right. kubectl expose deployment name. Geez, I already forgot it. rf tech np port is going to be 80. Name. Oh, whoops. This is rf deploy. Name is going to be rf node point. And then type node port. Exposed. Test your service. Validate that your service is responding via node port using a server's IP address. It works. Nice. All right. Using load balancer service. One 192.168.6.50 through 168.6.55. Oh, it help if I typed it correctly. Meta load balancer is enabled. Create a load balancer service. All right. kubectl expose deployment name, rf load balancer, port 80, name, type load balancer. Cool. Test your service. kubectl get service. And then 2.168.650. Clean up. Now that your tests were successful, you can clean everything up. You can use delete. Service. Node point. RangeForce deploy. Cool. Probably because it is a deployment. Cool. All right. What a great little Kubernetes challenge. Get some overview. Get acquainted with Kubernetes and scale up your applications. Learn fault tolerance, the load balancer. Shout out to RangeForce, always doing it right. Thanks so much for these community challenges. I really enjoy them. See you in the next one.